So here's problem number 14 from the test preview for AP Statistics. This multiple choice question says that a one sample z-test for a proportion at a significance level of 0.1 will be conducted on the following set of hypotheses. So the null hypothesis is that the population proportion is 0.5. The alternative is that it's less than 0.5. For which of the following is the probability of type 2 error the greatest? This is actually a pretty difficult question. A lot of things you have to consider here. First of which is you need to recognize what type 2 error is. So when you run a hypothesis test or a significance test, there's the truth for the situation, which is either that the null is true or the alternative is true. And then there's what we actually decide as the result of the test, which is either the alternative is true or the null is true. When we have this mismatch, we decide alternative, but it's actually supposed to be the null. That's type 1 error. Type 2 error is the other error that sits in the lower right within this table. The truth is the alternative, but we decide that the null is what's accepted. So this question is about type 2 error. So what's true about the situation is the alternative, but we decide that the null is going to fail to be rejected. So we fail to reject the null when we actually should. Now, if you look at these options, there are a few different things we have to consider. First of which is sample size, and then the second of which is which of these true proportions is the one that makes the probability of type 2 error the greatest. We'll talk about the sample size first. The way you're computing your test statistic, your z-score in this case, is by taking the statistic, the proportion measured from your sample, p hat, minus the parameter, that's the null hypothesis value that we're assuming to be true, and dividing by the standard error. Now the standard error for a proportions sampling distribution is going to be computed like this. We're dividing by the sample size. When we divide by a larger sample size, we get a smaller measure for standard error. When we divide by a smaller sample size, we get a larger value for standard error. Right? Dividing by a smaller value gives you a bigger end result. We would have more variability within our sampling distribution with this larger sample size due to that. So we are going to be able to eliminate any of these values with the larger sample size of 200. Now, options D and E both have the same sample size, so we're going to have to look at the true proportions in order to get the conclusion here. Let's think about this. Type 2 error once again. The truth is that the alternative is true. So the truth is this. The proportion is actually less than 0.5. But we decide that we don't have evidence that allows us to reject the null. We decide that the null cannot be rejected. Which of these proportions, being the true proportion, makes it more likely that we're going to get a small enough area for our left-hand tail that we're going to fail to reject the null? If the true proportion is this far beneath the null hypothesis proportion, right, 0.15 is fairly far beneath 0.5, especially in comparison with 0.45. This is only 0.05 beneath the null proportion value. This is 0.15 beneath. We are not as likely to fail to reject the null. It's a little bit weird to say. We are not as likely to fail to reject the null when the true proportion is further beneath it. Right? We're very likely to find evidence to reject the null when the true proportion is this far beneath the null hypothesis proportion. When the null hypothesis proportion and the true proportion are fairly close together, we are much more likely to fail to reject, and that's why we're going to decide on option D over option E.